This is Bob Capetta from the University of Illinois at Chicago, and this lesson is on the law of cosines. So here's the version of the law of cosines that most people remember. C squared equals a squared plus b squared minus 2ab cos c. Remember, angle capital C is opposite side little c. And recognize that this looks quite a bit like the Pythagorean theorem. C squared equals a squared plus b squared is what we know works for a right triangle. But the law of cosines is what we use for a triangle that is not a right triangle. You want to determine what various angles and sides are. We have one version of the Pythagorean theorem, but the reality is, for law of cosines, we can shuffle up these letters. So this is our fundamental version, but we could also go ahead and say b squared is a squared plus c squared minus 2ac cos b. Notice little b opposite big B. Notice little c opposite big C. Notice these two letters, a squared plus c squared, also show up here. These two letters, a and b, also show up there. So before I put up the next slide, see if you can construct the third rule that starts with a squared. So what would a squared equal following the same pattern of these two? And the answer to that is a squared is b squared plus c squared minus 2bc cos a. Now, the law of sines was useful for us when we had ASA triangles, when we had SAA triangles, and it even works for that ambiguous case that often shows up for SSA triangles. Law of cosines is going to be used for two other cases. We're going to start with the SAS triangle. Now, what that means is side, angle, side. I have two sides and the angle between them. If you have two sides and the angle between them, the law of sines will not work. You have to use the law of cosines. Now you'll notice the angle that I'm working with here is 120 degrees. So I'm going to need to have the formula that has cosine A. A is 120 degrees. I'm going to need to have cosine A, which means I'm going to have to start law of cosines with little a. Now what do we know in terms of our other notions here? This would be angle B. The side opposite capital B is little b, so little b is 7. Eight is opposite angle C, so this is angle C. 8 is opposite angle C, so little c is 8. So we have this information, and again, we can use our law of cosines, which is a squared equals b squared plus c squared minus 2bc cosine A. Little a is what we're looking for here. B squared plus c squared, 7 squared plus 8 squared, minus 2 times 7 times 8, cosine 120. Well, cosine 120 is one we should know. 120 degrees is in the second quadrant. In the second quadrant, cosine is negative. Reference angle is 60 degrees. Cosine of 60 is a half, but in the second quadrant it would be negative a half. So 7 squared is 49, 8 squared is 64. 2 times 7 times 8, 112, so minus 112 times negative a half. Well, minus will become plus. So 49 plus 64, 113. 112 times a half is 56. Oh, isn't this nice? A squared is 169, which is a perfect square. So a is the square root of 169. A is 13. So now what do I have? Now I have A, B, and C. I have three sides, and I have one angle. Can I find the other two angles? And the answer is yes. We're going to do that with what? With the law of sines. Now, it's a good idea to work off the largest angle first if you can, and certainly 120 degrees is the largest angle. But here's our story. So sine A over A is sine B over B is sine C over C. So we can use that to find what we're missing. So we have two angles that we're missing. I'm choosing to take a look at sine A over A equals sine B over B. So sine 120 over 13 is sine big B over 7. Then I can solve for sine B. How? 7 times sine 120 degrees is 13 times sine B. If I divide both sides by 13, I get 7 sine 120 divided by 13 is sine B. And of course we know that 120 degrees is in the second quadrant. Sine is positive in the second quadrant. Sine of 60 is root 3 over 2. So we could say 7 root 3 over 2 divided by 13, but I'm just going to go ahead and give you a decimal approximation. So that's sine B. Now, we know we cannot have a quadrant 2 angle because we've already used up 120 degrees, so the only answer here, of course, is a quadrant 1 angle. B is the inverse sine of 0.4663, or 27.79. I could use the law of sines again to get the measure of capital C, but it's not really necessary, is it? I have 120 degrees, I have 27.79 degrees, and the three angles have to add up to 180. So knowing that, capital C is 180 degrees minus 120 degrees minus 27.79 degrees, which gives us 32.21. So I have all three sides. Little a is 13, little b is 7, little c is 8. Big A is 120 degrees, big B about 27.79 degrees, big C about 32.21 degrees. So that was one SAS triangle. Let's take a look at another. So you'll notice we have angle B is 124 degrees here. This would be little a because it's opposite angle A, which is here. This would be little c because it's opposite angle C, which is here. We have angle B, so I need the version of the law of cosines that has cosine B. And you'll notice the one that I chose was B squared equals A squared plus C squared minus 2AC cosine B. I don't know what little b is, but I know little a, I know little c, little a, little c, and I know angle B. So that's enough for me to go ahead and evaluate it. So 15 squared plus 20 squared minus 2 times 15 times 20 times cos 124. 225 plus 400 minus 600 cos 124. So I have b squared is 960.52. B would be the square root of that. B would be about 30.99. So once I have that, right? So I have three sides and an angle. Once I have three sides and an angle, then I am able to go ahead and play with the law of sines if I want to go ahead and find those other values. So the way that would work, sine big B over little b is equal to sine big A, which we're looking for, over little a. That would enable you to solve for big A. You could do a similar thing to solve for big C. In both cases, we notice we have an obtuse angle. So angle A and angle C both must be acute. We don't need to concern ourselves with a second quadrant angle in that case. But I'm going to take a look at an SSS triangle next. Now, we have, again, our three angles, big A, big B, big C. So this is opposite big A is 12, little a is 12. Opposite big C, little c is 9. Opposite big B, little b is 12. Those are, excuse me, little b is 5. Those are the three sides we have, and we want to find the three angles. This is an SSS triangle. Now, here's how I approach this, writing down the relevant information. I chose to do C first, and I'm not really sure that was the best idea because you'll notice angle A has to be the biggest angle because it's opposite the larger side, the largest side. But let's go ahead and run through this, and I will show you how this is going to work. So our goal is to find what capital C is. C squared, 9 squared, is A squared, 12 squared, plus B squared, plus 5 squared. Minus 2 times 12 times 5 times cosine C. So 81, 9 squared is 81, 12 squared is 144, 5 squared is 25. 2 times 12 times 5 minus 120 cosine C. So we get 81 is 169 minus 120 cosine C. Subtracting 169 from both sides, I get negative 88 is negative 120 cosine C. So here I get cosine C is a positive number. I get cosine C is 42.83 degrees if it's quadrant 1. Now, looking at the way the picture is drawn, okay, it certainly appears that that's the case based on our sides. Cosine C is positive. It is not the largest side. Little c, which is here, is not the largest side. So therefore, it cannot be a quadrant 2 angle. But it's just good to think about that. Now, I'm going to do it again, and I'll tell you why. Because if I had used the law of sines to find angle A, I would get both an acute and an obtuse angle. And I'm going to have a problem. I'm not going to know which one it's going to be. So to rectify that situation, I'm going to go ahead and use law of cosines a second time. A squared is b squared plus c squared minus 2bc cos A. 144 is 25 plus 81 minus 90 cos A. 144 is 106 minus 90 cos A. And look at this. Look at what we have. We have cos A is a negative number. So that tells me right off the bat that I'm going to have a quadrant 2 angle. So I have to take the inverse cosine of 38/90ths to get the reference angle, then subtract that from 180. And what I get there is 115 degrees. Now, I guess the inverse cosine would also work. Inverse cosine of negative 38 over 90 would give you a second quadrant angle of 115 degrees. So that worked. I did the smaller angle first, and then I did the larger angle second, both using law of cosines. But you can save yourself a little bit of trouble if you just do the law of cosines for the larger angle first. If I had done this first, then I know that's obtuse. So I could have gotten angle B and angle C using the law of sines directly without having any issues of having two possible solutions. All right, so again, I'm going to go ahead and finish this one off. So those are the three sides. Those are the two angles. We know how to get the third angle. The three angles must add up to 180 degrees. So B will be 180 degrees minus 115 degrees minus 42.83 degrees, which gives me angle B of 22.17. So just a friendly suggestion, if you have a choice, if with an SSS triangle, try to find the largest side first. But if you find a smaller side first, then go ahead and use the law of cosines a second time to make sure that you don't have two different solutions, possible solutions to the same problem, when in fact, for an SSS triangle, there really is only one solution for you to work with. That will be the conclusion of this lesson.